Hello and welcome to my guidance video for Year 9s. This is the guidance video for Week 4's work. It's on nitrogen and fertilizers. So in the lesson that we're going to be covering today, what you'll need to do is you'll need to get your head around describing why it is that we need nitrogen, phosphorus and potassium containing fertilizers. You'll also need to be able to describe the displacement of ammonia from its salts, and you need to apply knowledge and understanding of balancing the equation for displacing ammonia, coming up with the apparatus, and also coming up with the method that we use when we are doing the experiment. And to extend you, I would like you to create a report on all of these facts in the form of a set of Cornell Notes. My biology students that I teach as well are very familiar by now with the Cornell Notes system, but there are some students that I do not teach biology to, so I will take you through the activity. So first of all, what you'll need to do is you'll need to watch my video that I have prepared. Now, it does have a little bit of biology content in there, but you are able to learn how to write the Cornell Notes, and I've got lots of information as to why it is that Cornell Notes is a really advanced way of making notes. You do need to make the notes in the style of Cornell Notes because I am really trying to stretch and challenge your presentation skills and being able to make judgments about information, ideas and quality of work to this set criteria. So really stretching and challenging you with the creation of a report in a format that you may not necessarily know about or are too familiar with. So open up the Google Docs document and give it the title. So the lesson looks like this, and give it a title. Your name, you need to put your name and then put Year 9 at Cornell Notes. So all you'll need to do is just start a new tab, go to Google, just go Docs, and go to a new document. So all of this is in the video. You can watch the video, it's very easy. You just need to do a 2x3, merge those cells, move this across to there and move this down, and you've got the start. Now each of these will need to be on a separate page, so the second page will need to be like this. So what you could do is, after you've stretched this out, you're going to put your name, your title, today's date and the page in this section over here. Your keywords, your key questions should be in there. So I could put something like the formula of ammonia, and in this one I would put NH3. Let's get that. Please make sure that you use the subscript and the superscripts. If you don't know what the shortcuts are, if you press Control and question mark, you will actually come up with all of the shortcuts in Google Docs, and right in the middle you've got superscript and subscript, and that is how I do all of my numbers. Okay, so once you've done that, you'll need to stretch this out. Your summary will need to go here, so just make a little bit of space there if you would like to. So your summary goes here, of the page goes here, and you'll need to have a summary for each of the pages. Okay, so I'm just going to zoom out a little bit and show you how you can save a little bit of time. You just go there, just leave that, get a bit of space there, and then if you highlight all of that, Control C, and then you just go after the document and you do Control V. You then have two pages where you have exactly the same thing. Now you are going to have a separate table for each page as your notes build up. You won't need this information there. So you can just wipe that. And all the new information can go in there. So that is how you will be going through your Cornell Notes making. Now, what you can do is you can copy the title from my slides. Now you will put your name there. So just change your name. There we go, that's my name, okay? And that will be submitted eventually as a document. And when I give you feedback, I'll be able to leave voice feedback. That's why I'm insisting on it being a document, okay? So the second step, once you've done that, and once you've watched my video on making Cornell Notes, then go through the material. Now, the material that I'm asking you to go through is linked to your lesson. So to make things easy, that document that I just came up with right now, that is now loaded. So if you really are struggling to use the ICT, you can save yourself a little bit of time by using my framework, but then can you please change your name on that one, and you can then go on from there. So the notes that you need to use are the notes that are on this page over here. So if you click on that, you should be able to load up all of the notes on ammonia and fertilizers. So I'm going to start taking you through this, so that you're quite clear on it. So you can see that the need is there to be able to describe nitrogen, phosphorus, and potassium containing fertilizers, describe the displacement of ammonia from its salts. That's straight from the specification. So the example are looking for that. So go through this. This is pretty self-explanatory. It talks to you about why it is that they just can't survive on carbon dioxide, light and water alone. They actually need to make proteins from amino acids. They can't really get that nitrogen source from the air. So what they have to do is they have to get it from the soil. And over time, if we have crops that are farmed, those plants remove the nitrogen. They also remove phosphorus and potassium, so we must replace them. Okay, so go through that. It talks about, my slides talk about the definition of the fertilizer, so you can put that into your Google document on Cornell Notes for this topic. And there's two different types of fertilizer that you need to be aware of. One of them is a natural fertilizer, which is animal manure. But then there's artificial fertilizer that chemists have been able to help with. So those are called NPK fertilizers because it's nitrogen, phosphorus and potassium that is replaced. Okay, the compound fertilizers may contain ammonium nitrate, ammonium phosphate and potassium chlorate. You can see that they are fertilizers which are compounds, and they contain multiple chemicals that can be supplied back to that can supply back nutrients into the soil, and the minerals that are used up by plants can then be replaced. Whereas a single fertilizer, you can actually have single fertilizers as well, and they only contain just the one substance, one compound. Okay, so single fertilizers will only have something like ammonium nitrate, and compound fertilizers may contain several different ones to replace everything that's been used in the soil. Up in soil. So making fertilizers, there's two processes that we will revisit later on in the course. One is Haber process and one is a contact process. The contact process is a chemical reaction that yields sulfuric acid. Haber is one that yields ammonia. And around about 10% of the global chemical industry is involved in making fertilizers. And potassium just comes straight from salts that are mined. So go through all of this. Go through why it is that we need lime to be put into soil. It's linked to work that we've just previously done on carbonates. That's why I set that work last week. The displacement of ammonia, that's a really important equation. You need to be able to balance this equation if you are given this equation without the numbers, and you also need to be able to complete the equation if you are given a description. So make sure that you understand what is going on here. This is when calcium hydroxide, lime, is added to a soil, and if the soil contains ammonium salts in the form of a fertilizer, so for example ammonium chloride, there is a chemical reaction between the two chemicals and it yields ammonia and calcium chloride and water. So lime reacts with water to form slate lime, that's the calcium hydroxide, that's why that's there, and farmers add that lime to the soil in order for the acidity to be dealt with. But if too much lime is put in the soil, it's not a good thing to yield this ammonia. So NPK fertilizers talks about that artificial fertilizer. This is fertilizers that contain nitrogen, phosphorus and potassium. So these are the different ions. You can see that's a single positive charge, single negative charge. Phosphate ions have a 3 negative charge. You don't need to worry too much about where those charges are or what electrons have been lost from what atom. You just need to worry about the fact that this is like a cluster, it's PO4, it's all together, and altogether there are 3 negative charges, okay? It talks about potassium, and I've got a lovely poster for you to understand why it is that we need to replace all of these elements and all of these compounds from the soil. So you can see, for example, magnesium actually affects the lower leaves. If you have a deficiency of magnesium, they turn yellow from outside going in, and the veins remain green. So you can tell if a plant is short on magnesium just by looking at the lower leaves of the plant. So please learn that. I've got a structure for you, which is the structure of the ammonium ion, so something for you to appreciate and understand. That's the shape of the ammonium. I've also done the same for the nitrate ion, because some of you may not necessarily be able to understand that these are actually real structures. The phosphate ion looks like this as well. The negative charges are on 3 of the oxygens, which are on the outside as well. And that's what the simple potassium ion looks like. I just thought I'd throw that in there. We have done ionic bonding and we have done electron configuration as well. And finally, we've got the displacement of ammonia. So I've just gone through that text again, and how the ammonium chloride salt can react with the lime if you add too much of your basic compound, your basic calcium hydroxide. You've got that forming. So if that was to take place, you get this reaction. Now, I've got a YouTube video over here that I found, and that takes you through the balancing quite extensively, and it's actually not too bad, so I just thought I would pop that in there as a link. So please go through that. You must be able to balance these equations for yourself, okay? Now finally, what you'll also need to do is you'll need to be able to understand how ammonia can be collected from the displacement reaction of ammonium chloride and calcium hydroxide. So we can actually replicate this reaction that takes place on farms if you add too much lime in the laboratory. Yes, you do need to know all of the bits of the apparatus. Yes, you do need to have a quick summary available for you to produce in an exam. So if they say, how can you prepare a sample of dry ammonia gas, you would draw that, you will describe it, you would say what the essential pieces of apparatus are, and you would go through this very quick description over here and over here. So the gas is actually dried using quicklime. So the ammonia gas is mixed with water moisture, water vapor that goes past here, but then you have pure dry ammonia gas. And ammonia is actually lighter than air, so it's okay to collect it using a dry gas jar up here. And that's about it. That covers everything. So I look forward to seeing your Cornell notes. Thank you very much for watching this video, and stay safe. Bye. Oh, and before I forget, straight after this, you have a quiz, a Google quiz on the classroom that you will need to complete so that I can assess your knowledge and understanding. And don't forget, the Cornell notes that you have to submit, they must be in a Google Doc, and please submit those as well. Okay, turn those in and stay safe. Thank you very much for watching. Bye.